Hello everyone. In this lecture, we are going to see the basics of 5G core. What is the basic architecture of 5G core? What are the basic elements that make up 5G core? And a little bit of brief description of each of these network elements. Okay, so the reference document which you can consult for these is 3GPP-TS 23.501 and 502, which give a little bit more elaborative on what 5G core components and constituents are. Okay. The objective of this course is to understand the network architecture and the network basic concepts which constitute a 5G core. Right. So first, we're going to see the network architecture. Then later on, we're going to see what are network functions, what are network SBIs, and what are the different interfaces and protocols that are used in 5G core network. Right. So in 5G core, basically we have two different types of architectures. The first one is called the SBA networking service-based architecture, and the other one is your reference point. So basically, in the SBA network architecture, you can see that the whole architecture is basically divided into two parts. This is your user plane, which is highlighted in green, and the one highlighted in brown is your control plane. So user equipment is something which is known. The radio access network is basically 5G radio. The rest of the components are all new. Okay. If you compare it with 4G or 3G and 2G, no network element is repeated here. So you have in signaling plane, you have access management function, you have authentication service function, you have session management function, you have slice selection function, exposure function, network repository function, the packet control function, the unified data management, and the application function. The names could be easier to understand, and the names can give a little bit of idea of what the functionality of each of these network functions are. The detailed description we're going to discuss later in the lecture. In the user plane, you have your user equipment, your access network, your user plane function, and your data network, which is also called your ISP. The difference between your reference point network and your SBA is basically the interfaces. As you can see that each network element or each network function has its own specific interface, like AUSF communicates on NAUSF, NSSF communicates on that. So these are basically communicating on what we call SBI, service-based interfaces. We're going to have a detailed discussion of what is SBA and SBI. The main difference to note right now is that the actual communication takes place on these SBIs in your control plane. If you look into the reference point, so a reference point is basically which is correlating with your earlier architectures. So, I mean, if we need to say that how does EMF communicate with SMF? So a straight away answer is that it communicates on N11 interface. Or how does your SMF communicate with UDM? It's on N10 interface, but this is just reference. The actual communication is done actually via your service-based interfaces, which is mentioned previously. So your SPA is basically for a control plane. The user plane runs on your reference interfaces, like you can see here. The QE communicates over N1 with AMF. AMF communicates with RAN over N2. RAN and UPF communicates on N3, SMF and UPF on N4, and then N6. So in reference point, we're going to see the same. N1, N2, N3, N6, and UPF communicates internally over N9 with another UPF. And if you're talking about the reference, so PCF communicates over with application function over N5, SMF and PCF over N7. But these are just a reference, all logical interfaces. The actual interfaces are basically the ones on the SBI. Just a little bit. Okay, so what is a service-based architecture? So service-based architecture, the main thing that you need to, the word that you need to concentrate is that it's decoupled and abstracted. So the different functionalities, like if you would remember in mobility management entity, MME was responsible for mobility management, but it was also responsible for session management as well. Your create session requests used to come to MME, and then MME used to forward it to SGW and PGW. So in SPA, the service-based architecture, as the name indicates, it's service-based architecture. So what the 3GPP have done is that they have divided all the functionality into different services, and then the common services or those services which were repeating, they were accumulated into a specific network function. Like AMF is responsible for access and mobility management. Okay, so your UE and your RAN is always going to be communicating with AMF. No other NE is directly communicating with this. Similarly, your session management, which was being managed earlier by MME and by SGW and PGW as well, so it has been accumulated into one network element on one network function called SMF. Your data storage and your subscription and all those were being done in HLR and HSS, and some of the information used to be saved in the MME as well. So all of that is now saved in UDM. So the control plane is basically your SPA, and your user plane is basically the traditional architecture. Okay, so your network functions are decoupled and abstracted into NF that are independently expanded. So if you need to do some expansion in AMF, you just need to expand AMF. Or if you need to increase the capacity of session management, you just need to expand SM. So you don't need to expand multiple NEs for one specific requirement. If you have an issue in your throughput, so you need to just expand your 2PF. The other highlight of SBA is that the NFSs are stateless. Each of these network functions do not carry any state. All the states, all the subscription information is stored in UDM or in UDRS. Okay, and SBIs, so your communication is done on service-based interfaces. So these are interfaces on which each of these NEs communicated on a specific bus, and that bus is basically communicating with the rest of the NEs. The NRF automatically discovers NFSs. An additional function which we're going to say later on is that of network repository function. So each of your NE registers itself whenever it comes into network, it becomes live, it registers itself with NRF, and that NRF is responsible for providing the IP address and the details of that specific network element when it is required by some second network function. So CUPS is used in the 5GC basic architecture. So your control and your user plane is separated. And another thing that is introduced in 5G is network slicing. Network slicing, we're going to discuss in a later lecture that how network slices are created, what is the purpose of creating those network slices, and how the network slices are assigned. So that is all managed by an SSL. The SPA can A further understanding of this is that SBA can be understood in terms of service provider and service consumers. So one network function is a service provider, and the other network function that needs to utilize its services is called a network consumer. So it's a communication between network producer to network consumer, request for a service from network producer, and network producer provide their service to the network consumer. Hence, it's called a two-way represented architecture. And all interactions are based on HTTP REST API. So the protocol which we'll see later on for all of the SBI is a common protocol. Earlier, we used to have GTPC, GTPU, diameter, and all those communications. So right now, in 5G architecture, in the control plane, all the communication is on HTTP and REST APIs. Okay, so a little bit of comparison of 4G and 5G network architecture. So I have highlighted the numbering, which will indicate that which functionality is done by which network element. So if you can see in 4G architecture, the MME used to perform function 1 and function 2, but the same function 2 used to be performed by PGWC and STWC, which we used to call CTW. So from MME, the access and mobility management function is comprised in AMF. Whereas the session management functionality from MME, HGW, and PGW is now coupled together into one network function, which is called SMF. Similarly, the PCRF functionality is now in PCF. Your HSS functionality is in your UDM. Your 3GPP AAA server we used to perform an authentication is your AUCF. And your user plane function, which used to be managed by SGWU and PGWU, is now composed into one network element, UPF. So as you can see that there were so many NEs which had multiple responsibilities. And if I had to expand MME, I mean, if I had to expand this signaling or the session management functionality, I had to expand MME. I had to do expansion on SGW, I had to do expansion on PGW. So right now in 5G architecture, if there is any limitation in session management, there is no need for me to touch AMF or PCF or UDM. I just need to expand SMF. So the basic difference is this. A little bit of more descriptive mapping and the functionality. So your AMF access and mobility management function is responsible for your connection, registration, reachability, mobility management, and it provides your session management between UE and SMF. So in EPC, it used to be done by MME, here it's done by AMF. Session management function is responsible for IP address allocation, user plane, section policy enforcement, quality of service, charging, roaming. So this functionality used to be done by all these three NEs. MME, your SGWC and your PGWC, so now it's been combined into one network function called SML. Authentication service function, which used to perform authentication for 3GPP and non-3GPP. So that used to be usually done by MME and HSS combined, and now it's been done by AUSF. User plane function provides user plane functionality like routing of packets, enforcing the policies, quality of service, reporting any traffic, and any routing of traffic towards specific servers. That used to be done by SGW and PGWU, which we used to call DGW. Now it's been done by one NE called UPF. The packet control function PCF is responsible for your policies and defining different rules and policies. So it used to be done by PCRF. Now it's called PCF. UDM is your unified data management. It used to provide user data management. It is used to perform authentication, identification, authorization, and used to manage the subscription information. So that used to be done by HSS. Now it's done by UDM. Three new network functions are introduced, which did not exist in 4G or earlier networks. These are your network repository function, which is responsible for registration and discovery of different network functions. Network slice selection function is basically maintains all the slices, and whenever a UE requests for a specific service, it provides the slice accordingly. And the network exposure function is for exposing the NF capabilities for internal and external information and communication. Right. So now this is a little bit of description of roaming architectures. So if a user is roaming in a visitor PLMN, and obviously he belongs to a home PLMN, so what are the different network elements which are going to be used in his communication in the visitor side and in the home side? Here I have uh, uh, highlighted those network functions which are usually different. So in visitor side, the user is going to have the radio access network, which is obvious. And then the user will be using the AMF of that specific visitor roaming partner as well. From in the home ELMN side, the user is going to use the UDM, and the user is going to use AUCF, and user is going to use the data network. The rest of the NEs are basically common. So in the visitor side, you're going to utilize the SMF as well, and in the home side as well, you're going to utilize the SMF as well as other uh, other network function as well. The NE that is used to communicate between the visitor PLMN and the home PLMN is SCPP. It's Security Edge Protection Proxy. In 4G and earlier, we used to have the DRA for signaling communication. We used to have border gateway. So here it's now called Security Edge Protection Proxy. And these are basically in the SBI form. The interfaces are mentioned in the SBI form. And if you need to look into the interfaces from the reference point, so these are the different interfaces. Like your SMFs are going to communicate. Earlier, they used to communicate over GP or S8. So now they are communicating over N16. Right. So next, we're going to look into different network functions. Like each of these NE is, earlier it used to be called network element. Now it's called network function. So the first one is AMF, the access and mobility function. As you can see in this architecture, let me just add pointer as well. So as you can see in this architecture, the AMF is situated here in the 5G architecture. So AMF basically communicates with RAN over N2 interface, and it interacts with UE over N1 interface as well for authentication, registration, and handover. Only one UE can be connected to one AMF at a time. Like previously, one UE could be connected to one MME, or one UE could be connected to one SGSN. So here it can connect to one AMF only. The AMF relays all the session management related information to SMF. So obviously the UE has connected with AMF. So AMF is going to communicate via an AMF, and on the SBI bus to your NSMF to your SMF. It relays all the SMS messages to SMSF. Obviously, if you have the SMS functionality has here as well, which is called SMSF. So all the SMSs are being communicated from UE to SMSF. And location information is relayed to your LMF. Right. Okay. In unlike 4G, the UEs in 5G has a specific interface, which is known as your N1 interface. It also relays any policy-related information to your PCF. and it is responsible for authentication, authorization of GUIs in cooperation with the AUSF and UDM. This we're going to study in detail. We're going to study the security functions and how security authentication is done in 5G. Similarly, it is responsible for deriving the keys for integrity and ciphering. In anyways, it is similar to MME. However, it does not provide any session management function. If you remember, MME used to provide session management functionality as well. And it has an interface with MME for context transfer and EPC. So if we have a combined EPC and 5G, so it will have an interface with MME to transfer the context when a user shifts from 4G to 5G and vice versa. The second network function which we're going to see is your session management function. It is located here in the architecture, and it has the main responsibility to set up the connectivity towards data network as well as manage that connectivity. It is responsible for providing the IP addresses and maintaining the session. The IPs can be IPv4, V4, and V6, and IPv6. It indirectly communicates with UE because it does not have any direct connectivity with UE. Like in 4G, we used to have S1 Q interface where UE used to directly communicate with your SGW. So here it does not have any direct connectivity, so obviously it is going to communicate via AMF. Compared to EPS, which we already saw, it is a combination of MME and SGW, and it communicates with other network elements obviously via service buses. Okay, so this is a service bus and service-based interfaces, so it communicates over that. It communicates with PCF for retrieving different policies, and it is also responsible for creating CDRs as well. So online and offline charging. The charging data is basically collected by SMF as well, and then it sends it over to CHF, which is the charging function in 5G architecture. And data notification is being held by it for idle if a UE is in idle state, so it is responsible for maintaining or managing the data notification for those user equipments. The third function which we are going to discuss is your user plane function. As its name indicates, it's responsible for handling the user plane data. So it processes and forwards the user data, which is controlled by the SMF. It connects with the external IP networks. It also generates the data records, traffic usage data records, which can be sent to SMF, and then SMF sends it to your CHF. Like the previous nodes functionality of DGW, it is responsible for buffering of the downlink data for idle mode UEs and implementation of different quality of service policies, restriction of data, and all that. And compared to EPS 4G, the UPF is basically what your DGW or your SGWU and PGWU used to do. The next network function is your UDM, Unified Data Management. It is somewhat similar to what HSS used to do. So it's Unified Data Repository. Okay, it's the front end of UDR. So UDR is another component, the Unified Data Repository. We're going to discuss it in the next slide. So UDM is the front end of UDR. And UDR basically stores all the user subscription information. Well, like I said, that all of these network functions are stateless, so they do not itself contain any information or store any state. That is basically stored by the UDR or UDFR. So UDM, it uses the subscription data which it gets from UDR for authorization, registration, and reachability for SMS. It attaches the 5G UDM, and UE attaches to 5G UDM, perform the checks like barring and restriction, A similar functionality which HLR and HSA used to do to see if the service is allowed and if any restriction and barring is there. It generates authentication credential during attached process. The keys, your authentication keys in 5G, these are generated by your UDM. Another functionality is to convert SUKI into SUPI. SUKI is basically a subscription concealed identity, and SUPI is a subscriber private identity. In the next slide, we're going to see what is SUPI and SUCI. So its conversion from SUKI to SUPI is done via UDM. Also, your UDM keeps a track of which AMF is serving a user. Similar to HSS, HSS used to have the information which MME is currently serving the UE. So here the UDM tracks which AMF is serving a user. And just like HSS, your UDM is always located in your home ELMN. And compared to EPC UDM, EPC UDM is similar to HSS in some aspect. The next network function is your authentication server function, AUSF, and it is basically responsible for authentication of the information that is received from your UE. So something that used to be done by MME and HSS earlier is now being done by AUSF. PCF packet control function is similar to PCRF. So it is related to provide different quality of service, different charging control, different policies and restriction. Now PCF interacts with SMF as well. PCF interacts with AMF as well, with AMF for access and mobility control. For example, if some access is controlled in some specific areas, so that policy is implemented is created in the PCR or implemented by the AMF. So it communicates with AMF as well, and it can also interact with UE to update the discovery and selection policies for non-3GPP networks as well. So PCRF usually earlier used to communicate just with your TGW. Now it's communicating with both SMF, AMF, as well as UE. Network exposure function is responsible for exposing the different network function capabilities and services which may be required by your application function. We're going to see a little bit of detail of any functionality when we go into the advanced topics of 5G architecture. NSSF is your network slice selection function, which is purely related to selection of different slices when a U request for a specific service. And it selects a network slice. It determines the allowed NSSAI, and if needed, the mapping to the subscribed as NSSAI. Now, what NSSAI and SNSAI is, we're going to look into it. We discuss the slice selection function and how it works. And it determines an AMF set used to serve the UE or may determine a list of candidate AMF through NRF query. So if UE is requesting for a specific slice, so that slice may be handled by a specific AMF or a specific set of AMF. So your initial request is going to go to this AMF, and then AMF is going to ask the NSSF. So based on the slice that is provided, the AMF is going to query the NRF for a specific AMF that is going to handle the service related to that specific slice. Okay. The next network function is your network repository function. It provides the services and provides service and NF discovery, and it's responsible for basically maintaining the information of all the network function. A little bit of more descriptive here is that it keeps a track of all your network function. Whenever any network function comes live, it is added in the network. It needs to register itself with the NRF, and it registers itself with what information, what is the type of the NF, what is its address, what is its capacity, what are the different supported services, what is the address for each running instance. So if any other network function needs to communicate with a second network function, it is not going to have a direct static mapping assigned. Like previously used to have that, okay, this MME is going to communicate with this uh, SGW based on which tracking area it is, or this MME is going to communicate with PGW2 based on the specific APN. No, here it is always, if AMF needs to communicate with the SMF, it is going to go to NRF and inform NRF that which sort of services it, it needs. And based on that, NRF is going to select that, okay, this SMF can handle all the services that are required by the AMF, and that NRF is going to provide that IP address of that specific SMF to AMF. So if registration, for example, a new PCF comes into the network, so that PCF is going to provide its all information to NRF. The NRF is going to store the information related to the PCF and then send an acknowledgement. Now, if an AMF here, an AMF needs to utilize the services of a PCF, so it is going to send a request to your NRF, and it is going to specify the which certain services are required. And NRF is going to search within its repository that which PCF can handle these services, and then it is going to send back a list of the PCF which are meeting the requested criteria. And based on that, the AMF is going to communicate with that specific PCF. So this is the main functionality. A little bit of similar functionality what DNS used to do, but DNS just used to have some static mapping as well. The NRF is a whole new entity which not just contains the IP information, it has the services, the list of service information as well. Okay, the next network element which we discussed in introduction UDM is UDR, the Unified Data Repository. So like I mentioned that all your subscription related information is not stored in your network function. It is stored in your UDR. So all the subscription data from UDM is stored in the UDR. All the policies are not stored in the PCF, they are stored in the UDR, and PCF then retrieves from UDR. All your network capability information for your NEF is stored in the UDR as well. So any when it gets any service request, it then goes into your UDR, it fetches the specific information and does the required processing accordingly. The other NE that we have here is the UDSF. UDSF is basically unstructured data service function, and it is basically responsible for storing and retrieving unstructured data. So any network function that has any unstructured data which does not make any sense, that is always stored in the UDSF. And hence the name we get is that every network function is stateless, is that the status data is split from the network function and is stored at the data layer. Data layer is this, which makes the network function status. So the network function, if your AMF goes down, if your SMF goes down, it does not have any data related to a specific user, its sessions and all that. So it is not going to create any service impact. Its place can be taken by another AMF because all the states are being saved in the UDSF. Most status data is closely related to carrier information and it's difficult to standardize. Hence, it's the unstructured data which is saved in UDSF. The next functionality is your CHF, the charging function. So it is an integrated charging architecture and service-based charging interface. Its interface is NCHF, and it is responsible for online and offline charging. And which NEs are responsible for charging? You have SMF, you have AMF, and your SMSF. SMF specifically is used for data service charging, whereas AMF and SMSF is responsible for charging your SMS. So SMF is going to both your AMF, SMF, and your SMSF are basically uh, communicating with the CHF in order to charge. Right. The next thing is basically the three-layered architecture. Whenever you are deploying a network in 5G, it is usually deployed in three layers. The first layer is your centralized layer. The centralized layer are those network elements which are basically centrally located. So in your existing EPC, you used to have your HSS and PCRF, SGW, PGW, and MME. Now, if you deploy a 5G network, so you're going to deploy it in two data centers. So the nodes which are going to be centralized are NRF, NSSF, UDM, HSS, PCRF, and PCF, your AMF, and your SMF. The second layer are those NEs which are required to be deployed at the regional end, which are those NEs. Those are usually your user plane function and your PGWU, because the user is directly communicating with the user plane function for data services. So you need to have least amount of latency over there. So your UPF or your DGWs in 4G and earlier architecture need to be deployed at the regional layer. And your centralized layer and your regional layer is connected via full mesh. So if you have two data centers available, so each data center is going to be connected with each of your UPF, each of your regional UPF. Like you can see that DC1 is connecting with UPF1, UPF2, and UPF3. Similarly, DC2 is connecting with UPF1, UPF2, and UPF3. The third layer is your edge. Your edge and networks are those which need to be provided very, very near to your access that network. Like you have your CDNs which are deployed, you have your UPNs which are deployed, you have your MSCs which are deployed. So each of these are basically deployed at the edge of your region. So three-layered architecture, one is the central, one the regional, and one are the edge nodes. Okay, so in terms of cloud deployment, you have your hardware, you have your cloud OS, and then in the VNF, uh, is specifically for uh, uh, Huawei architecture, you have UNC, which basically consists of in 5G components are AMF, SMF, NRF, and SSF. The 4G components are MME and SGWC, and the 3G, 2G component are SDSM. Similarly, this second VNF is UDG. In 5G, it consists of UPF. For 4G and below, it consists of PGWU. The third VNF is your UPCF. In 5G, it has PCF. In 4G and below, it has PCRF. And the fourth ENF which we deploy is the UDM. Here for 5G, you utilize UDM, and AUCF. For 4G, you have HSS, and for 3G and below, you have HLR here as well. So a little bit of description of these. So UNC, since it consists of AMF, SMF, and MMESGS, and NRF and NSSF as well. So it is responsible for managing subscriber mobility and session, discover NF select network slices. It can work as ES and MME SGW and for additional network as well. It can connect with multiple RAT, and it provides microservice-based architecture. 2DG is basically responsible for user plane functions. So it combines the 5GC UPF with SGW and PGW. It delivers high performance flexibility to cope with extreme bandwidth, and it supports the distributed deployment as well. UPSF is your PCRF functionality, so it is responsible for policy control and QoS for 5G and below networks as well. UDM is responsible for authentication and authorization, and it functions for both 5G in terms of UDM and AUSF, and for 4G, 3G, 2G, it works for HSS and HLR as well. And as per its functionality, it achieves quick service provisioning, reduces data synchronization, and navigate difficulties in internets as well. Okay, so what are the different network functions that 5G core network has? So we have NRF, NSSF, AMF, SMF, UDM, AUSF, PCF, UPF, SMSF, and NEF. And which interfaces are not service-based interfaces? So this is a tricky question. So all your interfaces that are in the user plane are not service-based. Service-based interface, if you remember, are for control plane. So for user plane, all the interfaces are not service-based. So N1, which is between UE and AMF, N2, which is between your access network and AMF, N3, which is between your access network and UPF, N4, which is between your SMF and UPF, N6 is in between your UPF and data network, and N9 is the interface that was between two UPFs. So these are all not service-based interfaces. Okay, next we're going to look into what are SBIs. So like we discussed, the control plane is service-based interfaces, and these are service management. So we have different services which are coupled together into one specific network functions. So the interface that carries the information and communication is your SBI, service-based interface. Okay, so if your microservices, the microservices are basically what constitutes in each of your network functions. So all NFO control can interact with this service-based interface. Okay, and this way you can have flexibility in meeting different scenarios requirement, because all of these interfaces are communicating on the same protocols. So you do not need to define multiple protocols for communication of maybe AUSF with NEF or AUSF with PCF. The protocol is going to be the same. Right. The network function of the core can be secured in the form of services through SBIs. These services can be invoked by other network functions as well. Right. So each of these network functions basically have different functions services as well. Okay. So AMF is a network function, and AMF is responsible for giving out different services as well. So this part basically introduces that what are the different unique services that AMF is providing. And this will then correlate with how your network repository function comes into play, and how the actual communication with different network function takes place. So AMF provides 4 different services. The first one is your communication services, okay, like communicating with SMF and PCRF. And it enables one AMF to fetch the content from another AMF. Okay, so if AMF needs to communicate with another AMF, it needs to invoke this communication service and allow for subscription to status change that is also required by communication. The second one is your event exposure. Event exposure means that you expose your events to other network function. For example, if UE reachability, UE mobility changes, UE is detached, UE is attached, registered, not registered. So all these events that are noted by the AMF, if any other network function subscribes to this event exposure, so this AMF is going to send that triggers or notification to those specific network functions as well. NAMF empty, it allows other network function to ensure UE is reachable. So if any network function needs to check whether U is reachable or not, it needs to invoke this empty functionality to communicate with AMF, and that AMF is going to check and confirm whether U is reachable or not. Location functionality, if any network function needs to check the location of a specific UE, it needs to invoke the service of an location in order to check the location of the UE. If you remember, we'll go a little bit back, and maybe you will understand a little bit more that when I was introducing the SBA architecture, it was a service producer and service consumer. So, but when we're discussing AMF is a service producer, and those are the four different services that AMF has: communication, event exposure, empty, and location. Service consumer is the network function that may utilize those services. So if this service consumer is, let's say, SMF, and SMF needs to know the location of the UA, so it is going to communicate with AMF, which is the service producer, and it is going to ask that what is the location of the user. Since this service is a functionality of your AMF to provide location, so it is going to check the location, it is going to provide back to the SMF the actual location of the users. So this two-way communication basically helps in communicating of these different network functions, right? So like this is the communication. This service name is communication. What are the different service operation that you can do communication? You can do the context transfer, which can be requested by peer AMF. So if your AMF changes and you're registered with the new AMF, so the new AMF may ask the old AMF for you context transfer. So it is going to use this service name, AMF communication, to request for the context, and as you go to similarly create UE context if a user is creating a new session, that is going to be done by the peer AMF. Release UE context. So these are all the specific service operation which need to be done, and these are the peer MEs, the peer network function. These are the service consumers which may request for this service from this specific AMF. Similarly, event exposure, a peer a peer node can subscribe to this service and it will get a notification. It may unsubscribe to this service and will get a notification, and it may notify itself for some. For example, NEF is going to notify of some service over event exposure. If AMF is going to subscribe to it, these peer NF are going to send a notification. Similarly, your UE reachability and domain selection information may be requested by your SMF and SMSF and UDM, and your location information may be requested by your GMLC and UDM as well. So this is an example. If you can understand this example, so you can correlate with the others as well. So the service operation is UE context transfer. Its description: provide the UE context to the consumer NF. Input: what input is required, 5G GUT is required or SOUP is required, the access type is required, and the reason is required, that why are you asking for a context. The input optional can be integrity protected messages from you that trigger the context transfer. There may be some condition based on which the context is done. The output that is required from this AMF is the UE context or the identify UE or the SOUP and indication that the registration now is not there. Okay, so via this NAF communication, UE context transfer, so you can transfer the context from one AMF to another AMF. Another example is your registration status update service operation. So service operation name is this description. This service operation is used by the consumer NF to inform AMF that a prior UE context transfer has resulted in UE successful registering with it. The UE context is marked inactive in AMF. This is what happens when you are connected with one MME and then an inter MME tracking area upgrade or inter MME handover is done. So your new MME has all the information of the users. So it is going to request the context from the old MME. And once the context transfer is done, the new MME then informs the old MME that you need to remove its context and mark it as inactive. So similarly here, if your context transfer is successfully done based on this, and all your information is now available in the new AMF, the new AMF is going to inform the old AMF that okay, you need to mark your context as inactive. So the input required is 5G GUTI and the status that it is now active over here. And optional can be PDU session IDs and the PCF ID so that it can release the PDU session and it can intimate the PCF that the policy has changed. Okay, so the new AMF will inform to old AMF that registration status PDU ISIN to be released due to slice not supported. If the AMF has changed, the new AMF informs the old AMF the registration of the UE in new AMF is completed by invoking this specific service. Yes, so this is how your communication between two network functions take place. Now coming to SMF. SMF has two different services. One is your PDU service, PDU session service, and the other one your event exposure. The event exposure, I believe, you're going to see in each of the network function that event exposure is offered by it, and any of the network function can subscribe to it so that if any event takes place specific to UE, it can be automatically informed to the peer network function who has subscribed to this service. So your PDU session can be create, update, release, create context requests, and all that. Event exposure is same: subscribe, unsubscribe, notify. And here, uh, what are the events which can be reported? UE IP address changes, the PDU session is released, the user pin path changes, the access type is changed, PLM minister. So all these, if happens, and AMF, NEF, and NWDF have subscribed to it. So AMF is going to automatically get a notification that okay, the UE IP has changed, or the PDU session is released and all that. So this is basically for automatically get an update of the user related event. So AMF, so event exposure is done with AMF, NEF, AF, and this, and then PDU session can be informed to your AMF and as well. SMF, okay, so create SM context service. A little bit of description of this. So it's used by AMF to create an AMF SM association to support a PDU. The AMF will provide what? The SUPI, the DNN, the AMF ID, and other parameters. The SMF is then respond back with the SMS context ID, the PDU session ID, and any N1 SM messages that need to be transferred directly to your UE, or any N2 messages that need to be directly transferred to the RA network. In case of your update session management context, it allows the AMF to update the association to support a PDU session. The AMF may include the SM context ID. It may include any N1 SM messages or any N2 SM messages which are provided by the UE and the access network to be provided to the SMF. And release SM context, it is used by the AMF to release the AMF SMF association. So when your PDU session is released, so this is used by AMF to release any SMF AMF association. In PCRF, PCF provides 6 different services. It provides policy control, policy authorization, for access management policy control, and this is session management policy control. Then you have UE policy control, you have event exposure management, and BDT policy control. So similarly, the communication is going to happen like we discussed in AMF and SMF. Any service that it needs to communicate with, if it needs to communicate with AM to inform any policy control, it is going to communicate with AMF. If it needs to communicate with SM, it is going to create, update, and delete via this SM policy control. messages. The AM policy control is access control network selection to the AMF, policy authorize and create of policies which are requested from AM related to PDU session, SM control policy for SMF. The BDT is basically provides a background data transfer policy to NEF. So NEF may ask for a background data transfer. That policy can be sent to the NEF by the PCA. The UE policy control is to be sent to the specific UE, and event exposure is obviously related to any events that are occurring in the network. UDM provides 5 different services. It has an SDM service, it has a UE context management, UE authentication, event exposure, and parameter provision services. So context management service allows for a UE context to allow NFs like AMF, SMF to register and deregister with the UDM, and can provide a network function with the related information to E like UE's NF identified status, etc. Subscriber data management, it manages the subscriber data and enables the different network function to retrieve the subscription data, which can maybe used to allow specific service usage or to bar specific service usage. The authentication is for creating your different data keys and then providing the authentication related information to AMF. Event exposure allows each and every NF to subscribe to any event that is happening in the UDM. And the parameter provision is used to provision information which can be used for UE in 5G. So any provisioning that is done in the UDM is done via parameter provision. NRF is basically responsible for network repository functions with service keys are service-based architecture. It centralizes and automates the configuration, which we already saw. Discover, select, and connect to peer NFs. And 3 services: NF management, NF discovery, and access token. NF management is for registration and managing an NF and their capabilities. NF discovery is to allow the other NF to discover the service provided by a specific NF. And access token is to request the authentication 2.0 access token that can be used for access services from other NFs. In this slide, we can see a little bit of functionality of NRF because it's a new functionality, a new network function. So, for example, we have a service registration procedure. So this service consumer, let's say AMF gets registered in a network. It is newly created, newly scaled. Okay. So once it comes live into the network, it is going to send an NF register request to the NRF with the specific information about what is the address type, what is the name of the NF, what are the service it's supporting. And NRF is going to store the NF profile and it is going to send a response. And in case a network function is being removed from the network, you're scaling it down, it is going to send a deregister request to the NRF. The NRF is going to mark the NF consumer as unavailable, that is no longer available, and send a response back. If there is an update procedure, if there are any changes in your network function, for example, you change its IP address or you're changing any other attribute associated to it, so it is going to send a management request and an NF management request to the NRF. It is going to update the profile of that network function and response back. And service discovery, if a network function, for example, AMF, is asking for a PCF, so it is going to send an NF discovery request to the NRF, and NRF is going to see that which specific PCFs are available and to send a response back to the NF discovery request. So this is the main functionality of NRF to manage and maintain the profile of different network function and then provide those specific network function as per requirement. Similar to it, how your registration and your update is done. This is a simple example of how NRF works. So a PDU session request comes to AMF. AMF is going to send an SMF discovery request. It is going to send those specific specific services that are requested by the UE to the NRF and ask that, okay, I need an SMF with these specific services. So NRF is going to select an available SMF and is going to send the information of that SMF to the AMF, the IP address and all that. And then AMF is then going to send that specific network function service to that specific the SMF whose address is provided by the NRF, and it is going to respond back, and then your PDU session is completed. Right. So what are the difference between the different 5G NF interaction and EPC interactions, and what are the differences between discovery and EPCs? So this is something who can answer once you can go through slides and see that what are the main differences between EPC and 5G and how the discovery and any selection is done. Right. Lastly, you're going to see the different interfaces and protocols. So as we already saw, N1 interface is the interface between UE and AMF, and it is used to transmit the NAS signaling between UE and core. And these are the different NAS messages: mobility management, session management, SMS management, UE policy, and all that. And when you access the AMF through 3GPP, each mode has an NMAS NAS signaling connection. So, and this security context exchange between you and AMF is also done over N1 interface. N2 interface is the interface between access network and AMF. And here the communication is done, which is basically not relevant to UE. So any procedures which are not relevant to UE, those are done between the AMF and AN over N2 interface, such as it, setting up or resetting connectivity between AMF and AN, and UE related procedures such as NAS messaging, UE context management, PDU, and all that. So these all sorts of communication is done over N2 interface. The SBI interfaces, like we saw, AMF, SMF, all that, these are working on similar or common encoding and decoding protocol. It depends on which protocol you're using, but its protocol stack is like L1, L2, IP, TCP, HTTP2, and then the application. So all of these interfaces have the same protocol on which they communicate. And unlike EPC, where we used to have different protocol for different interfaces, it does not take place here. In your control plane, or the communication is done on a common protocol. N4 interface, the communication is done in the control plane is via PFCF, CP, and in the user plane, the communication is done over GTPU. N4 is the interface between SMF and UPF. Right. N3 and N9. N3 interface is between your access network and UPF, and N9 interface between the two UPFs. So all this communication takes place over GTPU. Right. So next, you're going to see the basic mobility management concepts that are introduced in 5G core. And in the mobility management concept, the main thing that we will be focusing in this lecture is your subscriber identities and their location identifiers. So the first permanent identifier that is used in 5G is SUPI, subscriber permanent identity. It is somewhat similar to IMSI. It's a unique identifier which is allocated to each subscriber in 5G system and is provisioned in UDM and UDR. SUPI may either contain IMSI or network-specific identifier. In case of 3GPP, it's usually IMSI. In order to enable roaming services, just like in IMSI, the SUPI shall contain the address of the home network. So it will always contain the MNC and the MMC and the MNC. For interworking with EPC, the SUPI needs to be always based on IMSI to enable you to present an IMSI to EPC. So SUPI and IMSI are usually the same. And even if they're not the same, they need to be converted to each other in order to ensure that your interworking between EPC is done. SUPI is never transmitted like IMSI is transmitted or initial attach. SUPI is never transmitted, and SUPI is protected over radio interface using the SUKI. So your SUPI is converted into SUCI, and then subscriber conceal identifier is then transmitted over radio interface. The other permanent identifier is GPSI, General Purpose Subscription Identifier. It is a public identity of a user equipment inside and outside 3GPP subscription data of the SUPI and is possibly an MSISDN or an external ID. Third one is your permanent equipment identifier. So PE is allocated to each user equipment like handset. PE represents either it is your IMEI or it is your IMEI SP. So the name has changed, but the actual information or the actual representation is the same. Okay, the next we come to the temporary identifier. The first temporary identifier that we're going to see is 5G GUTI. Like in 4G, we used to have GUTI as well. So in 5G, it's called 5G GUTI. And this is allocated by AMF, like GUTI used to be allocated by MME. Now here is allocated by AMF. And AMF can allocate 5G GUTI to a UAT at any time. So 5G GUTIs consist of MCC, MNC, AMF region ID, like your MME pool ID, then AMF set ID, and then AMF pointer, and then 5G IMSI. So 5G GUTI consists of two components, the GUAMI, and the 5G TIMSI. The GUAMI consists of your MCC, MNC, and AMF identifier, and further your AMF identifier consists of region ID, set ID, and pointer. Now, one AMF may be correspond to multiple GUAMI, and if you check the mapping between your 4G GUTI and 5G GUTI, so your in 5G MCC is the same as 4G MCC, and 5G MNC is the same as your 4G MNC. The 5G AMF ID and AMF set ID are basically mapped to your MME group ID and your MME code. And AMF pointer is a part of, basically, one part of MME code becomes your AMF pointer ID, and one part of your MME code becomes your AMF set ID. And your 5G TIMSI maps to your MTIMSI in 4G. Right. Similar to STIMSI, that is in 4G, we have 5G STIMSI as well, which constitutes of AMF set ID, AMF pointer ID, and your 5G TIMSI, temporary mobile subscriber identity. The other important temporary identifier is your subscription conceal identifier. Like it's mentioned here, it has no equivalent in 4G. In 4G, when you are doing an IMSI attach, you send the whole IMSI. In 5G, you do not send your SUPI. You always send your SUCI. So it's a preserved identifier containing the concealed SUPI. It's a one-time subscription identifier. It's one-time use. And a different SUPI is generated after one has been used. So every time a user is communicating, it is going to send a different SUCI. A UE shall generate a SUCI, so it is generated by the UE using a protection scheme with a raw public key. So it can have a home network public key that was securely provisioned in the control of the home network. Both UE and home network can derive the SUPI from SUCIs. So this we saw in the description of UDM, that UDM basically derives SUPI from SUPI. So in SUCI, this portion is your plain text, and this is your ciphertext, which basically converts your SUPI to your SUCI. Location area. The location area identities are the same in 4G and 5G. It's tracking area ID and tracking area code. So 5G inherits the tracking area code based on mobility management, and the concept of TLS is also the same. Right. So which EPC concept are mapped to 5G SUPI? So SUPI is equivalent to an IMSI. GPSI is equivalent to an MSSDN. GUTI is equivalent to 4G GUTI. TAI are the same in 4G and 5G, and SUCI has no equivalent in 4G concept. What are these differences? 5GC supports 3GBP and non-3GBP. New concept must be introduced to unify the 3GBP and non-3GBP concepts. Right. So this concludes this first lecture of 5G core basics. I hope you got a better understanding on the basic architecture of 5G, how 5G network functions work, and how does the interaction between different network function. The rest of the components will be discussed in the later lecture. Thank you and have a nice day.